Now let's do a tutorial for a double definite integral equation. Example number 2. Double integral of f of x plus y dx dy. It's a double definite integral equation because it has two integral signs. Solution. Now what we're going to do here, we're going to take the first integration and we'll differentiate the given function f of x plus y with respect to dx. Differentiate this function with respect to dx. We have now x squared over 2 plus y times x. These are the limits, and put the value of these limits here. Put the upper limit first and then the lower limit. Since we have differentiated with respect to x, and therefore you must put the value of a limit in x variable, not in a y variable. This term will be 0 and we're left with integral of 1 over 2 plus y dy. The next step is to integrate the result whatever you get after the first integration. After the first integration we got 1 over 2 plus y. Now take the second integration. Just differentiate this with respect to y. After integration we have 1 over 2y plus y squared over 2. Put the limit from 0 to 2 and upper limit is 2 and our lower limit is 0. Now remember again here, since we have differentiated this with respect to y, and therefore you must put the value of limit in y variable. Solve it further and we got 3. This is our final answer. Now let's do one more example for a double definite integral equation. Example number 3. Double integral of 2x minus 2y dx dy. We can see here that in the first integral sign with respect to x, the lower limit is y. It is a variable. It is not a constant. Now let's see how to identify the limits graphically. We have a graph x-axis and here is our y-axis. Here is our function. The yellow line is our function where x equals to y. At this point x equals to 3 and y equals to 3, and therefore x equals to y. Here our x equals to 3 and our y equals to 0. Now look to the first integration with respect to x. The value of x equals to y and the lower limit is y. It starts from y up to 3 and the upper limit is 3. Since x equals to y and therefore the lower limit is y and the upper limit is 3. Now in the second integral sign with respect to y, the value of y starts from 0 up to 3. So the limits are 0 and 3 for the y, and that's how we identify the limits graphically. Now solution. Take the first integration and integrate the given function with respect to x. After integration we have integral of 2 times x squared over 2 minus 2yx. Integration of 2x is 2 times x squared over 2 minus integral of 2y is 2yx. These are the limits. The lower limit is y and the upper limit is 3. Now put the upper limit first and then the lower limit. Now remember again I repeat it, since we have differentiated with respect to x, and therefore you're gonna put the value of the limit in x variable, not in y variable. Solve it further. Now the second integral sign and integrate the value whatever you get after the first integration. Just integrate this with respect to y. and the limits are 0 and 3. Expand the limit here. Divide 6 by 2 to have 3. The upper limit is 3 and the lower limit is 0. Again, since we differentiated it with respect to y, and therefore we put the value of the limits in y variable, not in x. Solve it further. This is the final answer for this equation.